Welcome to the deep dive. Today we're tackling something pretty cool, actually. How can you build powerful responsive apps without ever, managing a server yourself? We're going deep into AWS Lambda's basics. We'll look at how functions get started, these things called triggers, and how timeout and memory settings are like your control knob for performance, and yeah, cost too. Plus, the sort of magic behind its execution model that just handles everything.
Yeah, exactly. Our goal here is to break down these core pieces, show how they make these event-driven systems possible, and really why getting these fundamentals is, well, absolutely key if you want to properly use serverless. It's moving past just using Lambda to really understanding its power.
Okay, right. Let's unpack that.
Yeah.
The whole serverless promise is code runs only when needed. But what actually makes it run? What kicks it off?
Good question. It really boils down to triggers. Think of them as events or actions that tell your Lambda function, okay, time to run. So imagine you upload a picture to Amazon S3. That upload, it can automatically trigger a function to, say, resize it.
Oh, okay. Like an automatic reaction.
Precisely. Or think about your website. HTTP requests like GET or PSD coming through Amazon API Gateway. Those can directly trigger a function. Or maybe you change something in your Amazon DynamoDB database, add a new record, modify one, that action itself can instantly start some process. And there are others too, of course. Amazon SNS, SQS, CloudWatch events, EventBridge, even just calling it directly, manually. Lots of options.
That's really flexible. So many different starting points. But how does Lambda actually connect the event to the right function? And does the thing that triggered it, wait around?
Right. So the how is basically configuration. You link a specific event source like that S3 bucket to your function. When the event happens, Lambda gets sent a JSON payload. It's just data packed with details like, which S3 bucket, which file.
Got it. Context for the function.
Exactly. Now, about waiting. That depends. You have synchronous invocations. Think API gateway. The caller makes a request and waits, right there, for the function to finish and send back a response. But then you have asynchronous ones, like those S3 events. The function gets triggered and just runs in the background. S3 doesn't wait. And for those async ones, Lambda has built-in error handling. If something goes wrong, it can automatically send the failed event to what's called a dead letter queue, or DL queue, so you can look at it later.
Okay, so triggers kick things off, either waiting or running in the background. But once it's running, what are the rules? How long can it run? How much horsepower does it get? That sounds like timeout and memory.
Yes, absolutely critical settings. They really define how your function behaves, how fast it runs, and importantly, how much it costs you. So timeout is pretty straightforward. It's the max time your function is allowed to run. Could be just 1 second or all the way up to 15 minutes. It's 900 seconds. If it goes over that limit, Lambda just terminates it, stops it right there.
Prevents infinite loops and surprise bills, I guess?
Exactly. Prevents runaway costs. You set it based on how long you expect your code to take. Then there's memory. You allocate memory from 128 megabytes up to 10 gigabytes now.
Wow, 10 gigs. And I remember reading that memory isn't just memory, right? It affects CPU power, too.
That's a key point, yes. More memory allocation also means proportionally more CPU power is assigned to your function. So if you have a task that needs a lot of processing, crunching numbers or something, giving it more memory can make it run much faster. And here's the interesting bit. Sometimes bumping up the memory can actually lower your total cost.
How? Because it runs faster.
Precisely. Even though the price per millisecond might be higher for more memory, if it cuts the execution time drastically, the overall bill can end up being smaller. Plus, you also get access to a temporary storage space, that temp directory, which is now up to 10 gigabytes as well, useful for temporary files during execution. And you can track all this stuff, find that sweet spot. Use Amazon CloudWatch Logs insights to see how much memory is actually used and how long things take. Optimize from there.
Okay, that makes sense. Triggers, timeout, memory. It feels like we're building the function's profile. But how does AWS manage all of this behind the scenes, especially at scale? That must be the execution model.
That's the magic, yeah. The execution model is how Lambda handles everything. It's fundamentally event-driven, only runs when triggered. It's also stateless by default, meaning each run is independent. It doesn't remember anything from the last time it ran unless you specifically use external storage like DynamoDB or S3, and each time it runs, it gets its own secure, isolated environment.
So what's the life cycle like? When an event comes in, what happens?
Okay, so first time an event comes in for a function that hasn't run recently, Lambda needs to set things up. This is called a cold start. It involves finding a server, loading your code, initializing any dependencies. This adds a bit of latency. Milliseconds, sometimes a second or two.
Ah, the infamous cold start latency.
Yeah, that's the one. But then your function code actually runs, processing the event data. Now, here's where it gets efficient. If another event comes in soon after the first one finished, AWS will often reuse that same environment it just set up. That's a warm start. It skips all the setup loading code, init stuff, so it's much, much faster. Any global variables you defined outside your main handler or data in temp might still be there from the previous run.
Okay, so it tries to keep things ready if possible.
Exactly. And for applications where even that small cold start latency is just too much, there's something called provision concurrency. You basically pay to keep a certain number of environments pre-warmed and ready to go instantly. It costs more, obviously, but it guarantees low latency. But the big picture here, AWS handles all this scaling, patching, server management. You don't touch it.
Right. So wrapping this up, we've seen how triggers are the spark, making functions react to events. We've seen how timeout and memory are your controls for performance, for cost. And this execution model is the clever engine underneath, handling the scaling and isolation automatically.
Absolutely. And I think the real beauty of Lambda, especially if you're just starting out, is that simplicity. The auto-scaling is huge, and the pay-per-use model is, well, fantastic. You really only pay for the compute time you consume, down to the millisecond. It lets you just focus on writing the code that matters for your application, not managing the servers underneath.
So thinking about all this,
Yeah.
the triggers, the resource controls, the hands-off scaling, how does hearing this make you think differently about building things? Knowing that the infrastructure can effectively just vanish until the very moment it's needed makes you reconsider some traditional approaches, doesn't it?